Okay, for some reason, Cami wigged out on me. So I already had part of this written down. Y equals 3 times quantity x plus 2 squared plus 4. This is what we call vertex form. Now, you should be able to graph this using transformations of functions. These red dots here are the parent function ordered pairs, right? Because 0 squared is 0. Okay, so that's why 0, 0 is on there. 1 squared is 1. And then 1, 2 squared is 4. Okay. All right, that's parent function. To graph this, you're going to use transformations. This says go up 4. And this says don't go to the right 2, go left 2 units. And this is a stretch. Okay, so to graph this using transformations of functions, I'm going to take the vertex. I'm going to move it left 2 and up 4. 1, 2, 3, 4. That's going to put me right there. Now, from this point, remember, I already used this part and I already used this part. My function now is x squared times 3. So if this was 0, 0, then this right to the right of it would be my 1, x is 1. We know 1 squared is 1, but I have to multiply by that stretch of 3. So again, I go from here, 0, 0. 1 squared is 1 times 3 is up 1, 2, 3. Okay, I'm going to use the axis of symmetry to draw the corresponding point. From the vertex, I'm going to say x is 1, 2. 2 squared is 4, but multiplied with 3, I have to go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right here. Axis of symmetry. I'm going to draw the AOS. Remember, the axis of symmetry goes right through the vertex. And you should label the AOS with its equation. This happens to be x is negative 2. And I'm going back to blue to graph that other point. I'm 2 units away from the axis of symmetry on the right, so I have to be 2 units away from the axis of symmetry on the left. And so this is my new parabola that is stretched by 3. Okay, it's a little bit difficult on this tablet writer for me to graph parabolas because you get the idea. I'm coming through here, going through that point, coming back up. I'm going to try one last time. Okay, that's a little bit better. Okay, there is my graph. Now, if we want to look at problem number, let me pick another one up quick. Let's look at number 15. This one was number 12. This is 15. Okay, the function is y equals 2 x plus 3 quantity squared minus 3. All right, so for what we know, transformations of functions, remember we did this with absolute value. I'm going to be going to the left 3. This subtraction means I'm going down 3. This means a stretch of 2. Now keep in mind, if that was a negative, your parabola would be opening upside down, okay? I don't have any on this little screenshot that I took of the worksheet with a negative out front, but I could always make another video for that kind. All right, parent function. If I wanted to draw the parent function, I got 0, 0, 1, 1, 2, 4. Axis of symmetry is the y-axis. Okay, so there are the coordinates for the parent function. I'm not going to draw the problem. I am now going to use these transformations down and left. So I take the 0, 0, and I'm going to move down 1, 2, 3 units and left 1, 2, 3. This is my new vertex. this is technically 0, 0. Those 2 points are the same kind of point, meaning it's the vertex. You could immediately draw the AOS to go right through the vertex point right away to help you with graphing. Okay, so there is my vertex. And now from this point, I'm going to say to the right 1 unit is when x is 1, 1 squared is 1, but I have to stretch by 2. So I'm here. And since that point is 1 unit away on the right side of the axis symmetry, the corresponding point would be 1 unit to the left. All right, so back to the vertex. X is 1, 2. 2 squared is 4. Multiplied with 2 is 8. So I have to go up 8 units from this point here. 1, 2, 3, 4, 5, 6, 7, 8. Notice that point is 2 units to the right of the axis symmetry. 2 units to the left would give me the corresponding, or the Q prime point. And then I'm going to connect my points and form a parabola. Let me know if you still have any questions or if you need to see one where the leading coefficient is negative. Okay? Have fun with the graphs.